Good morning, class. Welcome to another learning session in pre-calculus. Last time, we illustrated the different types of conic sections: parabola, ellipse, circle, hyperbola, and the degenerate conics. This time, we will be defining circle. Alright. Did you know that circle is considered a special kind of ellipse? Alright, to illustrate this one, we will be using the previous discussion we have last time. So here we have two inverted cones, and we also have one plane because we need this inverted cones and plane to come up with conic section. Now, if the plane is tilted this way in such a way that it intersects only one cone, forming bounded curve, we can actually come up with an ellipse. We can also change. We can also come up with an ellipse in that case. But what happens if the plane is horizontal? So therefore, we can come up with circle. So this is what, according to this statement, that circle is considered a special kind of ellipse. Now, but I will be emphasizing this one later as we move on to our discussions with ellipse. Alright. So what is circle? Now, we will be using GeoGebra to define what a circle is. Now, in the junior high school, we learned that a circle has a fixed point. So, let's say this is the fixed point in the XY plane. Let's say we call it C, whose coordinates are H, K. And we will be introducing point C on the XY plane. Point P, we will be calling this one point P, whose coordinates are XY. We can change the location of P anywhere we want. In this case, suppose you would like to get the distance from C to P. The distance is actually 4. Now, if you would like to change the location of P right here, P can be here, anywhere you want. And if we collect the set of all points with the same distance from the fixed point C, we can actually form a circle. Suppose we can have another circle this time. So in this case, the distance from point P to point C, the fixed point, the distance is 5. If we would like to get its distances from the fixed point to anywhere along the circle, it would also give us the same distance as 5 in this case. So formally, we would like to define what circle is. Through this presentation, let's say we have a given point. The set of all points P having the same distance from the fixed point C is called circle. Now, the point C is called the center of the circle. Of course, we learned that one in the junior high school. And the common distance is what you call the radius. This part right here. Now, we will be using this concept to derive the standard form of an equation of circle. But before that, we will also be needing the distance formula. So, for example, given 2 points, let's say x1 and y1 in the xy plane, and we also have another point x2, y2 in the xy plane. We would like to get its distance from one another. That's basically equal to, we will be denoting it with d. That's actually equal to the square root of the square of the difference between x1 and x2 plus the square of the difference between y1 and y2. That's the distance formula, the distance between any two given points in the xy plane. Now, in this case, suppose this is our x1, y1. This is our x1 and y1, and this is our x2, y2. Now, suppose we would like to get its distance. In this case, the distance from C to P is r. So we would just write simply r is equal to CP. C and P are again they are points in the xy plane. So to get its distance, we will be using the distance formula. So the distance between them is basically equal to the square root of the square of the difference between x1 and y, x1 and x2. X1 is x2 is h, so we have x minus h square plus y1 minus y2, so y1 is y, y2 is k, so y minus k and the quantity square. Suppose we would like to square both sides to get rid of the radical. So we are left with r square is equal to the quantity x minus h square plus the quantity y minus k square. And this time we can just interchange. I'm going to write this one first, followed by r square. So I will have x minus h square plus y minus k square is equal to r square. This one is actually what we call the standard form. So we call this one standard form. This is the standard form. Standard form of an equation of circle. Standard form of an equation of a circle. Where of course the center, through our presentation right here, the center is at HK. Center, I'm just going to denote it with C. This is our center. And when we say R, we're just simply dealing with the radius. Alright, so that's it, class.